and welcome to my new lecture. Now I'm going to show you how do you label power supplies in electronic circuits. So here now we have two types of electronic circuits. Here we have a battery with a lamp, and here we have electronic circuits with two resistors in parallel. Now I put a lot of amp meters and voltmeters here because I want to show you what's the amount of current going through these resistors and this lamp, and I'm going to show you how do we label power supplies in electronic circuits. And this is very important. Just wait a second, I want to change the value of these resistors. You shouldn't now do anything here. You can just watch. You don't have to copy what I'm doing right now. I just want to show you how do we label DC power supplies. How do we mark? How do we how do we connect? How do we draw power supplies in electronic circuits? So this is kind of a physical way. How do we do it? Here we have a battery, here we have plus and the minus side, and this is in real life the same thing. You have a plus or a minus battery, but I will show you how do we do it in how do we draw it so it could be a lot more easier, and we would have a lot more space to draw electronic components on a schematic, and it saves some room and space. But this is the physical way. How do we connect this simple circuit? So it's not that hard, but you need to have intuition. So let me just go here, set animation options, show wire currented with arrows, and when I simulate the when I run the program, as you can see now here, this is like in the first few tutorials we have. Now we have here a battery, half amp goes through this lamp. We have 12 volts here. Now we have here about 11.9 volts on this resistor. We have 0.54 amperes that goes through this resistor 1, and we have 0.30 amps that go here through this resistor. Of course, the voltage drops are the same because they are on the same potential. Yeah, and I showed you that in last lectures. But now I'm gonna show you another way that we can draw and see how can we connect this. So now I'm gonna show you a conventional type of labeling power supply. So here in this left toolbars, how do you say it? I don't know. You go here to the generator mode. So now if you want a DC generator, DC power supply, we go here, click on DC and put it here. Now I'm just gonna put some. First I'm gonna put some parts here. So fast forward. Now I'm gonna first put some parts here. So and then I'm gonna explain it to you what is going on here. Okay, just a second. Let me just do my thing. Okay, here we go. Let's put now. Here, okay, and 1 voltmeter so I can measure the voltage. Now, in electronics, this is the conventional way. How do we label an electronic power supply? So here you can see that this circuit is much more nicer than this one here, but this is the same circuit. So for example, for the DC power supplies and the AC, the plus sign of the battery is labeled like this, and the minus sign we use this symbol that is called the ground. So let me just and now here we have a 12 volts, and when I click here or left click on here, now we can change this to 12 volts, so like so, and the current always goes to the lowest potential in the circuit. So ground is a zero potential. Now we have voltage across this point, that's 12 volts, because that's the voltage is a different potential. Here we have 12 minus 0 volts, that's 12 volts. This is the same thing like here. And now when I run the program, as you can see, here we have 0.50 amperes that goes through this lamp. We also had here that 0.5 amperes that go through this lamp here, and we have 12 volt droppage here, and also we have 12 volt droppage over here. So this is, and as you can see, that now it says it's a plus of the battery, but you can change the name if you want. We usually say that's VCC or VDD. I don't know. It all depends on the components. And as you can see, the ground is now the minus side of the battery, and here this like a little triangle here, and with a line here, this is the plus sign. So this is how I am going to label electronic circuits, and it's like, you know, when you draw this, when you see something like this, you know this is the plus sign of the battery and this is the ground. So, you know, it's a nice thing to know, because as you can see, it's much nicer and cleaner than this. It's easier to draw circuits like this than here. So it's not that hard, but you know, you just have to work and have intuition and routine for this. And now I'm gonna draw the second circuit. Okay, now I'm just gonna put out this lamp, click delete, and I'm just gonna delete this one, and I think that should be okay. So now, how do we label two resistors in parallel? Okay, so here we have two resistors on this. Oh, I'm sorry. We have two resistors in parallel, one with 50 ohms and one with 40 ohms. So here we have the plus potential. As you can see, here's the plus potential, and here on the right side we have a negative potential. Negative potential is ground in electronics, and the plus is this triangle here. So now when I put two resistors in parallel, normally I'm gonna change their resistance. Let me just connect this one and this one, and now let me put one resistor here in parallel. Here is the plus side. Of course, sorry, I'm gonna put an ammeter here so we can measure. Oh, just a second here. Okay, just a second. I'm gonna put a DC ammeter over here, so we are gonna measure the currents, and you will see it's the same circuit. And now let's just connect. Oh, okay. I think you know what's going on. It's not good to connect wires like this, but you know it's not a problem. So, and I put a ground on this resistor also, and just a second. And as you can see, this resistor R3 is on the same potentials as the R4 here and here. So this is the minus sign, minus potential here, and this is the plus potential here. Ammeters don't have a internal resistance, so they are idealistic. You should just imagine that there is a short circuit, but I put ammeters here so we can measure the current. And let's say this is 50 ohm. Oh, I'm sorry. This is here 50 ohms. and here we have 40 ohms. And now I'm gonna show you the voltage drop across these resistors. Just oh, sorry, just here and here and here. And now when I run the program, as you can see, through the resistor R with 50 ohms, there is a current 0.24, and here in this same circuit, where is 50 ohms, here we have a current that goes 0.24 amps across it. So sorry for my English. And here in this circuit where there is a resistor of 40 ohms, there is a current that goes through it, and it's equal to 0.3 amps, and here you have 0.3 amps. Also, the voltage drops are 12 and 12 ohms. Why does it say here 12 and 12 ohms, but here it says 11.9, 11.9? This voltage source doesn't have an internal resistance, and this one has 1, so it's 0.1. But it's not that big of a deal, because that is almost the same thing. This one doesn't have the voltage. This one supply doesn't have the internal resistance, and this one has one. So that's kind of it for this tutorial. Also, I'm just gonna delete all this. Also, you can put an AC sine generator like so, and you can change the amplitude, the RMS or the peak voltage. It's up to you. You have the amplitude, you can change the frequency, you can choose the RMS. It's up to you. You can choose the offset, but I'm not gonna do that right now. And you have the phase degrees, damping factor, that's kind of a period or a free, and you know, it's the practically that's the same thing. So I think I showed you how do we label power supplies in electronic schemes. So that's it for a lot for this video, and see you in my next video. Bye everybody.